So let's proceed again with the next problem for IPE industrial plant and power plant topics now. So if it's a Carnot engine, remember that the Carnot engine, like most engines, no, it's an ideal engine. No, the efficiency of the Carnot is simply the work net over the heat added. Okay, and also since this is a Carnot, we can say that this is equivalent to the difference between your maximum temperature over the maximum temperature. The difference between the maximum and the minimum over the maximum, no? So in this case, since naka kilowatts, we'll just use dimension analysis, no? If it produces 12 kilowatts, so 12 kilowatts of power, and it receives, therefore, 1,500 kilojoules per minute is the heat added, no? So 1,500 kilojoules per 60 seconds. So the temperature of the hot reservoir and simply TH, no? Via shift solve, we can now solve for the hot temperature, no? Or you can use algebra. Really won't matter, no? Temperature should be around 19, no? 0.23. Oh, sorry. Since temperature should be absolute, no? If I can use this one, TH ko, TH plus 273 minus 10 plus 273, which is makakancel lang din. But the denominator is TH plus 273, no? TH is what? Pero makakancel lang din yun, no? Di siya really nagmamatter. Still gonna be the same answer. Since TH will be in 271.23 degrees Celsius, no? Okay. So for the second problem, okay, let's just put it here. Yeah, given na. Most of the items here are given, no? So again, we have evaporator, this is the compressor, and this is the condenser. Also, you have your expansion valve, no? Enthalpy at condenser entrance, this should be, let it be H, no? Enthalpy, let H be enthalpy, 482 kilojoules per kilogram. Condenser exit, you have H3, this is H3, 348 38.15 no? kilojoules per kilogram. And for H4, it should be the same kasi it undergoes an isenthalpic process no? Through a expansion valve. At evaporator exit, this should be H1 equals 48.14 kilojoules per kilogram. It should be easy, no? Since we have the equation COP between the evaporator and the compressor. COP is tons of refrigerating effect exerted through the evaporator over the work of the compressor, no? So this is simply H1 minus H4 over H2 minus H1, okay? But the compressor, no, is driven by a 100 kilowatts motor. So we can assume that is equal to 100 kilowatts. Pero you want the capacity of refrigerator in tons of refrigeration. So this is in TR and this is in TR as well. So 3.517 kilowatts per TR. Okay. So we just input the value here, no? Capacity. Okay. So the tons of refrigeration should be around, no? Or the capacity of the refrigerator should be around 58.35, no? TR. Okay. Yeah. So moving on. So same thing that we solved kanina, no? We'll just use the CP. Again, from 90 degrees to 40 degrees Fahrenheit. Nag-cool lang siya, hindi siya nag-freeze, no? We'll just use the CP. So we have 5,000 gallons, no? Per day. Pero within 8 hours. So we simply just use 8 hours, no? So for every gallon, mayroon kang 8.6 pounds. Just use the density, no? And the CP as well. CP is what? 0.935 BTU per pounds degrees Fahrenheit. And temperature difference is 90 to 40 degrees Fahrenheit. For every 1 hour, there is 3,600 seconds, no? The difference I use though is, since we want it to be in tons, now there are different ways to solve this, no? But I'm going to use the one I'm very familiar with. So yeah, cancel gallons, pounds, degrees Fahrenheit, hours, left with BTU per second. You can use any conversion, but this is the one I'm very familiar with, no? So you have, for every 0.70707 BTU per second, you have 1 HP. And for every 1 HP, you have 0.746 kilowatts, and then for every 3.517 kilowatts you have 1 TR, no? So again, you can use any conversion that you are familiar with, no? This should be what? So it's 90 minus 40 is simply 50, no? So TR should be around 20.94 tons of refrigeration needed for the milk to cool from 90 degrees to 40 degrees Fahrenheit, no? Okay, so this should be very easy. Again, what is COP, no? COP is the refrigerating effect over the work of the compressor. You have 105 TR and a compressor power input of 30 kilowatts, no? So either of the two, ipag-match mo lang. Pwedeng dito ka mag 3.517 kilowatts, 1 TR, or pwedeng sa taas, no? You multiply yung nasa taas. But it should be the same, no? COP should be around 12.095, no? Dimensionless, since this is simply ratio, no? Okay. Okay. This one, 500 HP refrigeration system, no? Okay. So if you want to use it in pounds per second, no, there are many ways to do it. Okay, so I'm not familiar with HP to BTU, no? I can use the traditional, or yeah, let's just search for the okay. So gawin natin yung traditional, no? Remember that Q either absorb or released, no, is equal to, if we're calling water, no, MC T. In this case, this P ang ginamit para ma-cool, and for every 1 HP you have pounds per second, no? Let's use the standard. The standard is 2544.4 BTU per R, and for every 1 R you have 36 seconds. Now the mass here should be in pound mass na over second, right? So HP BTU, R and R. So we're left with BTU per second. The CP of water, no, in BTU per second is 1. Okay, simply 1 BTU per pound mass degrees Fahrenheit, no? And temperature difference, if we account, so M should be what? M should be around 16.828 pound mass per second, no? Okay.